All right. Just like we did in the previous sections, you'll want to be able to calculate the sample size given the margin of error and the confidence level that you desire um, in the work that you're doing, in the research that you're conducting, or the survey you're performing. So we can do that with population proportions as well. And you'll notice that there are, two formulas here. And if you look at the difference between the two is that this top one has P prime and Q prime, are your sample proportion of successes and failures. And those two are missing, and they're just replaced with a 0.25. Well, with this bottom one, um, this is the equation you use if you don't know what the proportion of success is in advance in your sample. And so what you do is you just assume that the proportion of success and failure in your sample is going to be 50%. So 50-50. And it turns out that by assuming that both are going to be at 50%, it's going to maximize the sample size and give you the most conservative estimate for sample size that you can use. So this is kind of a unique thing where, if you're not given enough information, you can just kind of assume it's going to be 50-50 and use 0.25 in its place. All right. Just like previously, though, you always want to round up to the next whole number when determining sample size. So let's look at an example here. All right, so find the minimum sample size needed if the margin of error must be 2 percentage points. The confidence level is 99%, and the point estimate for the population proportion is 14%. Right in interpretation. So let's look at what's given. So the margin of error, we were told, must be 2 percentage points. All right, and we're going to write that as a fractional value here. Confidence level is 0.99, which means the significance level is going to be 0.01, which means the area in each tail is going to be 0.005. All right. The point estimate for the population proportion is 14%. So we're told that P prime or P hat is 0.14. And from this, we can say that Q prime is going to be 0.86. Okay, the proportion of failure. All right, so what do we need? Well, we need to calculate sample size. And so that's going to be Z alpha 2 squared times P prime times Q prime divided by the error squared. All right, we need to figure out what our Z alpha 2 is going to be, and we'll square it. P is 0.14 and Q is 0.86 all over E, our margin of error, which is 0.02 squared. So we just have to figure out what our Z alpha 2 is. So, looking at our distribution, we have a confidence level of 0.99, which is this area here. And the significance level divided by 2 is 0.005, which is this area here. Okay, so we have that amount on both sides. And we need to find our positive Z critical value. All right, so we're going to have an area of 0.005 with a mean of 0, standard deviation of 1 on the right. 0, 1, area on the right of 0.005. All right, let's see what value that gets us, and we'll save it in uh, our variable Z on the calculator. Okay, let me clear this. So we'll do inverse norm. Okay, the area is 0.005. Area on the right looks good. 2.576. 2.576. All right, so I'm going to store that in Z on the calculator. There we go. Okay, let's do this over here on the numworks. So let me hit the home button, go to distributions, backtrack a little bit. Okay, we're going to go to normal distributions because that's what we use with proportions. Mean of 0, standard deviation of 1. Area to the right. Okay, we want an area of 0.005. 2.576. So we'll take this and we'll store it in variable Z, like that. Okay, so now let's conduct this fraction. Let's simplify this fraction. So it's, let's see here. Yeah, I can just about see that. All right, so this is everything in the numerator. So I'm going to have Z squared times 0.14 times 0.86. And that's going to be divided by 0.02 squared, like that. All right, let me put that into the numworks calculator. Okay, so this is everything in the numerator. So we've got Z squared, oops, and then times 0.14 times 0.86 parentheses divided by 0.02 squared. Okay, 1,997.1 and some change. 1,997.1 and some change. So we get 1,997.1 and some change, which we have to round up. So it's 1,998. That's the sample size that we need in order to have a margin of error of 2% and a 99% confidence level. All right. Let me know if you have any questions.